from where we have to start?
Good morning.
Good morning, Abdullahi. What topic we did last? No one remembers. What was the last topic that we did? Where we stopped in the last class, guys? I think Murtala Bala was not there. Yeah. Lawal, you were there, I guess.
Yes, we stop at types of storage.
Yeah, types of storage. Very good. So, which storage we were doing? From where I have to start? Which type of storage? I told you about primary memory and secondary memory, right?
Yes,
Right. Then we did type of primary memory. Okay.
yes.
Yeah. So from which memory I have to start explanation?
Room.
ROM. Okay. Yeah. So RAM we did, right? We have completed RAM. Oyo, you were there in the
Yes,
last class.
Yes,
So I have to start from ROM.
yes, ma.
Yeah, types of ROM I told you there are two types of ROM, static RAM and DRAM, SRAM and DRAM, right? That I explained. Okay, I just share my file and now we have to start as Oval Lawal has told me we have to start from ROM. Okay. So till then, all of you please mark your attendance in the chat box. Yeah. If anyone has missed it. Yeah. Right. So I just share my file. Just a second. Yes. So is this visible to all of you? My PPT is visible to all of you?
yes.
Okay. So please all of you mute yourself. Some noise is coming from your side. Okay. And mark your attendance, right? So yeah. So yeah. It's visible all of you?
Yes, ma.
Okay, right. So this we did all types of memories. I explained that all types of memories can be divided in three types: internal and primary and what do you say? Secondary memory, right? So then, what type of memory come in internal memory? What memories come under internal memory category?
Registers and cache memory.
Sorry, come again.
Registers and cache
Yes,
memories.
yes, registers and cache memory. Yeah, good. So this is internal memories and Then I started with RAM, right? Types of RAM. And from here, I have to start today. This is ROM. ROM is your read only memory, right? And as I told you, RAM is called as a volatile memory. So that means it will lose its data when power is off. Okay. So this is called as a primary memory. Okay. So, but ROM is called as a permanent memory. Okay, non-volatile. So non-volatile means you will not lose your data even if power is off, right? So I told you, like, if you are doing something on your system and if power goes, so if you haven't saved it, so you will lose that data, because any file is opened in RAM only. Okay, so when you say why RAM is necessary, because whatever file you bring from the secondary memory, it comes to the RAM when you open it. Okay, so that is why we say more RAM means more speed, because at a time more space in RAM means you can open many files at a time. Okay, so but this is volatile. In case of ROM, as I am telling you, like, this is kind of we can say permanent memory. So what do you mean by that? You will not lose your data when the power supply is switched off. Okay, so as unlike your RAM chip, so the stored data in ROM chip we can only read that. Okay, that cannot be changed. That is why it is called as read only memory, right? Because it's like, as I told you in the last class also, it comes from the manufacturer only. Okay, so manufacturer, you can say, embed this chip in the machine, whichever machine it can be. Okay, it can be a computer also, it can be a microwave also, it can be, these kind of devices. So these devices come with already built-in ROM from the manufacturer. So manufacturer writes it and fix it in the device. So we cannot write it and change it. Okay. So this is your, that is why we call it as a read only. So this is non-volatile and it cannot be altered. Okay, so we can just not only performs read operation, okay, but restrict themselves to be altered, right? So this is why we restrict it to be altered. What is the reason behind that? Because we want it to be secure, okay, to be safe. Because if anyone can change ROM, so that means anyone can change the settings of that device. So what we write in ROM, which is not for the user to manipulate, so basically we write the instructions which are necessary for the computer to start. Okay, so when we say my computer is uh, what we call it, mounting, and there is one more term for that, it's not coming in my mind. So but when we say my computer is starting, so that time whatever data or files are necessary at the time of booting the computer, those files and those data is no kept in ROM. Clear? So this is designers program ROM chips at the time of manufacturing circuits. Okay, so as I said, manufacturer design these chips. Okay, so as I given you example, it like in your fully automatic washing machine, in your microwave, so there is some programming. Okay, there is some software, there is some programming which is working behind those buttons and settings. Yeah, just a second, let me complete. Okay, so that is embedded by the manufacturer only. Yes, now tell me what is your query. I think Nasiru raised hand. Yes, who, somebody raised hand. You want to ask some question? No one? Okay, fine. So I'll just continue. Okay, then we come to the different types of ROM. Okay, so different types of ROMs are, I'm going to explain one by one. So one is your M ROM, masked ROM. Masked ROM means which are hardwired, okay, and what is hardwired? The data or instruction. Now I explain this. Like as I said, what we have in Rome, we have some data or instruction which are required by the computer at the time of booting the machine. Okay, so now those data and instruction, when we say these cannot be changed, these cannot be altered, so that time what we do, we build them in the circuit. The manufacturer, what does he do? He build those instructions in the circuit itself, on the chip itself. Okay, why? Because if these instructions are fixed, that this CPU has to work on these instructions, then why to no like increase this cycle that CPU has to pick this from RAM and there and then execute it one by one. So what the manufacturer does, when this machine is made specifically for this purpose, so why not build these circuits of those data and instructions? So that is why this is written as hardwired devices. Okay, so what we do, the manufacturer wired those instruction and in the circuit itself. Are you getting my point? So there is no like CPU will pick this instruction and execute this instruction. No, those instructions are built on the chip itself. How it is built? Through the circuits. Okay, so circuits are made as per the instructions. Clear? So this is masked ROM, means what we call it normally as a ROM. This that same ROM you can call it as a masked ROM, because those instructions are hardwired or made on the circuits in ROM chip. Why? Because we know that nobody will alter them. So why? So they will just, you can say, embed those instruction on the chip itself. Clear? So nobody is going to change that chip or circuit made on that chip. Okay, so this is mass ROM, which we normally call it as a ROM, read only. Next is programmable, PROM. Right, what is programmable? Programmable is like which we can change, right, but once only. Okay, so where ROM can be altered or changed but only once, that is called as a programmable read only memory, PROM. So what happens, that after changing those instructions once, it will again become ROM. Clear? Because after changing the instruction one time, you cannot change it again. So that means after the PROM has been programmed, okay, so after that it becomes a ROM only. Okay, so this is like creating a ROM chip from scratch is time consuming and expensive process. So for this reason, what developers do, they create a type of ROM which is PROM, right? So what they will do, they will pick up some ROM, okay, which already have some instruction, and they will just change some parts of it, right? And it so after that it can never be changed. Okay, once PROM has been programmed, its contents can never be changed. After changing the program once, it PROM becomes a ROM only. Clear? So ROM means now it is ROM, which cannot be changed again. Okay, then this is again non-volatile. As I said, ROM is non-volatile, so it means that its content will remain intact even if the power is switched off. Okay, clear? Next type of third category of ROM is EROM, EPROM. Okay, erasable programmable read-only memory. What do you mean by that? This is programmable. Yes, we say this can be changed. Program PROM means programmable. But what do you mean by E here? E means uh, it is can be erased and erasable programmable. So what do you mean by erasable programmable? Means you can change it as many times as you want, right? So in PROM, what was the restriction? That you can change it only once. But erasable programmable means you can change it as many times as you want. But what you have to do for that, you have to expose your ROM to a strong ultraviolet light for a certain amount of time, then only its data will be erased and then you can again rewrite it. right? But what is the disadvantage? Like, advantage is you can erase it and recreate it, but the advantage is that this is not selective. If you have to change at one place only, you cannot be selective. You have to erase the whole row and then rewrite the from the beginning. Okay, so this is not selective. Like, you cannot select a area and erase it and change it. So you have to erase the entire row and then rewrite it. So this is more expensive than PROM. So next is fourth category is EEPROM, that is electrically erasable. So now what is better in this EEPROM? This is like, you can be selective. Okay, so you can change it as many times as you want, and then you can be selective also. So selective means you can change a part of it and no erase a part of it and change it. So like EPROM, you don't have to erase the entire PROM. So you can just erase a byte at a time rather than erasing the entire chip. Okay, through ultraviolet light. Here you can just erase one byte at also, right? How you can erase it? Through electrical charge. Here you can erase using electrical charge. Okay, so this is EEPROM is more flexible. Clear, guys? So this was the type of EEPROM. So these are very important questions. Types of RAM, types of ROM. Okay. Next we come, what is cache memory? Cache memory, as I said, like from hard disk, we bring data to where? Where we bring and keep the data from the hard disk, from the secondary memory, where it is brought and kept, because CPU will not go to the secondary memory. This is very far from CPU. So the data from the file in this secondary memory will be brought and kept where? Anyone?
It will be brought to the RAM.
Yes, so it will be brought to the RAM, right? So now, as I said, just a second. So as I said, this RAM, yes, you're right. We bring the data from secondary memory to the RAM, this primary memory. But again, I said this RAM is still far from the, what do you say, CPU. So
It's far from the CPU.
yeah, so that we don't want CPU to waste time in bringing and saving the data on the RAM. So we wanted some memory which is more closer to CPU, right? So it should waste less time in traveling the data, right? In receiving and sending the data, right? So receiving means when we open a file, so that time we bring the data from the file to the RAM. And sending means when we say save this data, whatever CPU has changed, now save that data permanently to my file. So that means when I write my content, so that time I send the changes to the secondary memory. So now we want some memory which is more closer to CPU. So that is the cache memory. Okay, because registers are on the CPU itself. Okay, so but registers, so there is one memory more layer between registers and RAM. So that is cache memory. So from RAM, we bring the data to the cache memory. Clear? So this is obviously to minimize the waiting time. Okay, so that CPU should not wait uh, for the data to come from the RAM. So this is 100 times faster than your secondary storage devices. Right, so when it fetches the data from RAM, that is 100 times faster than fetching the data from secondary storage. Okay, now the rate at which data can be fetched from main memory is 10 times slower than CPU processing speed. Okay, so obviously in this type, like where if it brings the data from the RAM, so still CPU is working at its 1/10 speed. Okay, so increase the performance of the CPU. What we want this waiting time or the speed mismatch to be minimized. Okay, so that is why this cache memory is used to minimize the speed mismatch between the RAM and the between the CPU. Okay, so this is a memory between CPU and main memory. Okay, and this is faster, obviously faster than main memory, right? So that the speed of the instructions executions can be increased. And which is more faster than cache memory? Which memory is faster than cache memory? Yes. RAM is
Registers.
registers. RAM is faster than secondary memory. Cache is faster than RAM. RAM, or we call it main memory also. Okay. Then which is more faster? Registers, because they are on the
Register.
CPU itself. So CPU doesn't have to wait for fetching the data or to any external memory, you can say. That is why we call it as a internal memory, right? Because this is on the CPU itself. Just a second. Yes, so these are registers, right? So a number of registers equal to number of bits that it can store. As I told you in the last class also, if you say 32-bit computer, that means 32 registers. And why we call it 32? Because each register can store 1 bit only. So 32-bit means it has 32 registers and each register can store 1 bit. Okay, so that is why we call it 32-bit or 64-bit register. Then this was all about your first primary memory. Then we come to the secondary memory, right? Now in secondary memory, can somebody tell me the features of secondary memory? As we have already discussed, what are the main features of secondary memory?
They are non-volatile.
Yes,
They are permanent storage.
yes, and
They are non-volatile.
it's non-volatile. Very good. Permanent storage and
And
They
part of
are
High
it can be
storage
erased.
capacity.
very
memories.
good.
Part
Cheaper.
of it can be erased and rebuilt again.
Yes, right. So this is cheaper, right? So these all are the basic features of secondary storage, as you all are aware. Now, these secondary storage devices, first of all, can be categorized in, no, it can be sequential access also and direct access also. Types of access is different in different secondary storage devices. Okay. Now, what is the type of access? What do you mean by that? First is your sequential access. Now, what do you mean by sequential access? Sequential access means if your secondary storage has, suppose, 100 records. Okay. So now, if you have to move to the 100th record, if you want to read that 100th record, first you have to pass all the 99 records. You cannot go directly to the 100 records. So that is sequential, right? So obviously sequential access is cheaper. Okay, this is cheaper. Now I give you one example. You have seen the types of cassettes we used to have, audio cassettes, video cassettes in old times. Anyone has seen that video cassettes, audio with that reel, long black reel, in audio cassettes also, video cassettes also, we used to have in, around previous times. I don't know whether you guys have seen it or not, because it's around 2 decades back I'm talking about. Has anyone seen it? Audio
Yeah.
cassettes, video cassettes. Yeah. So that was, if
Yes, we have seen it.
very good. So that was your sequential access. So that is the access example of sequential access. We call it magnetic disk. Okay, we call it magnetic disk. No, sorry, we call it magnetic tapes. Magnetic disk is your hard disk. We call them magnetic tapes. Okay. So magnetic tapes were like if you have to listen to 10th song, first you have to pass over 1 to 9 song, whether you listen to these song or you fast forward it. Even if you forward it, even then that means you have to pass through those 9 songs. It's just that you are doing it at a faster speed for forwarding, right? But you cannot directly play that song. Are you getting my point? But in CDs, if you have seen in some older movies, you have seen CD player like where you can put your, you can say reader at any place and you can listen to that song directly. Okay, CDs. We used to have CDs also. Nowadays these are very less no, not used so much. So but in CDs, that is the example of direct access, where wherever you place that reader, if reader, if you have seen in the previous movies or somewhere, right? So that is your direct access, but these magnetic tapes are the example of your sequential access. Okay, so uh, here these are cheaper, but advantages that these are cheaper, but disadvantages that searching is very slow. You cannot directly go to that particular record. Okay, is it clear to all of you what is sequential access? Yes.
Yes, it's clear.
Right, good. So this is your sequential access, and direct is, as I said, you can directly go to any record. Okay, so uh, so here we use magnetic disk or optical disk. So magnetic disk means hard disk, or optical disk means your CDs, DVDs. Okay, so these all come under direct access. Okay, so that means random access. You can go to directly to that information what you want, right? So this on this sequential access and direct access basis, we have divided all the secondary storage devices. So magnetic tapes come under sequential access device, and your magnetic disk, optical disk, right? So these all come under direct access devices. Okay, so we used to have the floppy disk also in earlier times. Okay, so floppy disk, hard disk, CD, so these all come under the direct access device. Clear? So now we will see how they work. What is the technology? So magnetic tape, as I said, these were very cheap. Okay, still they cannot still they can be used as for taking backups also. Okay, for you can say offline storage, because hard disk is installed in your system, right? So whatever you are doing, it is, you are saving that data in that hard disk, right, at the same time, right? So this is your online storage, you can say. So offline storage means you can just know some insurance companies, or where their data is their business only, right? And they have a huge data, so they can just store the data and they can just keep it somewhere else, not in their office. They don't, they want it to be secure, so they can keep it in some locker also, right? So these are very you can say cheap and reliable storage for taking backups or for archives. Okay, so but they are not suitable for files which you need or to update or read frequently. Okay, as I said, if you need to read and update some data frequently, that time you will keep it in hard disk, right? So which you can use on daily basis. Okay, and this is like in your online storage. Okay, but if some data is like 20 years back, like in insurance, some the policies go for, no, they continue for 20 years, 15 years, so they don't need this data on daily basis, so they can keep it at some other place also. But the data which you need to use frequently, that you do not keep it in magnetic tapes. Okay, so as I said, there were audio cassettes also, video cassettes also. So they used to come in different sizes. Their width could be half inch or 1/4 inch. Okay, and their length also could be from 50 to 2400 feet long, right? So this was your magnetic tapes. Next, what are the advantages? Large amount of data can be used, and it is a cheap mode of offline data, which I just explained. Okay, what is offline and what is the disadvantages? What are the disadvantages of magnetic tapes? Anyone?
Yeah, search of data is very slow.
Yeah, and they are sequential in nature.
It is slow in
So
accessing information or data.
slow searching, so you cannot read and go to your data directly, and then they have to be kept in dust free environment. Okay, and then they wear out. Okay, so if you have used those cassettes, uh, could be used to spoil in very less time due to dust also. So these are the advantages and disadvantages. Now next is magnetic disk. Now what is magnetic disk? As I said, your CDs, your hard disk, everything comes under magnetic disk. So first of all, they are fast because we can directly access the data from whichever data we want. We will directly go to that place and read that data. We don't need to read all the data one by one to go to the 10th record. Okay, now comes the uh, structural, like how it works. Okay, so I tell you, this is like, you can say, this is your hard disk, which is a platter of disk on one on the other. Okay, so hard disk means platter of rings, you can say a platter of disk. Okay, so this is your, just a second. Yeah. So data, uh, this like your magnetic disk. First of all, this is called as a online secondary storage, because as I said, in hard disk you keep the data which you read and want to update frequently, right? So now this is a platter of uh, many circular plate. Okay, so magnetic disk is a thin collection of many circular platters. Okay, now what how it works on all these different platters. So see what we do, these are the different platters, and now these platters are logically divided in tracks and sectors. Okay, because when we store the data in hard disk, and when we say open this file, or when we say save this data to this file, so that time how the operating system searches, like where you want to save, okay, or where you want to read the data from. So how it will search, because it has direct access, it has to directly go to that data. So how it will reach that data directly? It need to have some, what do you say, address. Okay, so wherever your data is stored, whenever, whether you read it or when you write a file, so write means whenever you update it, right? So that times the operating system will search your file through its address. Okay, so now how that address is calculated? So what we do, we divide this one platter in some circular partitions logically, not physically. We don't draw these circles. These are called your what? Concentric circles. They are called your tracks. Okay, so these round, as I am showing you, so this platter will be divided in some circular partition, which are called your tracks, and in each track this is divided in some pie shaped partition. These are called your sections. Okay, so whenever you say save this file, open this file, so that means it searches the address of that file through its track number and sector number. Okay, so track means in which circles, and in that circle which pie shaped partition, like this is your sector number. Is it clear? And these round partitions are your track number. But again, I am saying these tracks and sectors are the logical division, not physically you divide and draw these circles. When we say we have to format the hard disk, so what do you mean by formatting? Formatting, what happens in the process of formatting? Formatting means it will logically divide your hard disk in some track numbers and sectors number. Clear? Then all these circular platters, there are many platters in a hard disk. Okay, so many platters are stacked one above the others, and they all are divided in some tracks and sectors. Then they all move on, or you can say attached to one motor, you can say, which will rotate all of them. Okay, so this motor, you can say, where all these platters rotate are called, is called spindle. Okay, now wherever you want to read, whichever data you have to read, so for reading that data you have read and write head. So these are your read and write head. For reading also, for writing also, you will place this head on that particular track and sector from where you want to read the data or where you want to write the data. Okay, so this is what do you say, what I have explained, that these outermost to we give it a number from outermost to innermost to your tracks, these concentric circles, which will start number from 0 from outer to inner. Okay, and then this circles are divided into sectors, okay, which are pie shaped segments, you can say. And generally a disk has 8 or more disk sectors per track. Okay, but different disk may have different number of tracks, it's not fixed. Okay, so number of tracks is not fixed, and generally on one track you divide it into 6 to 8 sectors, 8 or more sectors, right? And we give it these circles a number starting from outer to inner, starts from 0. Okay, now these platters, multiple platters create one disk storage. Okay, so these platters are stacked on top of each other with a common spindle, which I just showed you, on which these move. Okay, and which turns the whole assembly, whole collection of this disk are moved by on this spindle only. Okay, and we keep a little bit gap between these platters. Okay, there is a minor gap, hairline, you can say gap. Okay, for read and write head, so which I am showing you, these are the head, read and write head. If you want to read data from this sector on this track, so this head will be placed on that position, on that address. Okay, as I was telling you, you must have seen this in some, older movies, like you used to place some read write head on the CDs. Okay, so this you can see as a series, but CD means a single platter, but in hard disk you have a multiple stack of collection of platters, right? So there is a read and write head for each side of the platter, right? You can see this one platter has two sides, so you can save data on the top also and on the bottom side of this disk also. Then on this platter again, there is top surface and bottom surface. On both the surface you can save and read the data. So for on each platter you have different read and write head for the different surfaces, for top surface, for bottom surface, for top surface, for bottom. So these are your read and write head. Okay, and these read and write heads are placed on, these are arms, read write arms. So these are called arms, and on each arm you have head, which is, you have different head for each side of platter. Clear? Now next is, suppose you have to read data from this sector, from this track on this platter. Okay, but these all, when suppose you were in outer track and now you want to place your read write head onto this track, right? So what you will do, you will bring this read write head on this address, right? So this address should come under this read write head position. So you will move this platter for that. so that this address should come under here, under this read write head. So when you move this platter, because all the platters move collectively, right? So whichever track and sector this first platters is, all the platters will be on the same track and sector, right? It's not that you have to read from one platter, so you will move only that platter. No, they all will move collectively. So their relative position on all the platters will be same sectors, and same track will be under the read write head. So this kind of organization, this you can see, this dash lines, this make what kind of shape? A cylinder shape. So this is called as a cylinder. Okay, so the concept is that all the disk, okay, so they all tracks are in the same position on the platter. Clear? Right? So this is called a
Yes.
cylinder, right? And all the arms are connected to this arm assembly. Okay, so this is the you can see how data is stored and read from the hard disk. Okay, so this will rotate, the spindle, this will rotate all the platters. Okay, and the all platters will be on the same position of track and sector, which will form a cylinder shape, right? So what are the advantages and disadvantages of this magnetic disk? You can easily move them, like you can carry hard disk easily from one place to another because very compact size, right? Then they can be used as online storage also and offline also. You can keep the hard disk in no install the hard disk in your system where you are working, and maybe if your one hard disk is full, you can keep it at some other place as offline storage, and you can keep it for no in somewhere else, not in your workplace. So that is, it can be used as a online storage also and offline storage also, right? So then low cost also, as you know, nowadays the cost of hard disk is very less, right? So GBs of data you can store in hard disk which cost very few thousands only. Okay, so then they are less prone to corruption or dust or temperature, as we have this in case of magnetic tapes. Okay, so you can say that the storage capacity is virtually unlimited, because in TBs of data, this is very huge data, right? So virtually unlimited, not technically unlimited. And what are the disadvantages? If your data is of sequential nature only, right? And if your requirement is like, I need to access data one by one only, I don't need to access the data randomly. So in that case, there's no point of using hard disk. Then this is of not much use, because in that case you can go for magnetic tape also, if you have to store and access your data sequentially only, right? Then you have to save it from protect it, that it should not crash, right? So this is some disadvantages, and obviously they cost higher than magnetic tapes. Now what are the different types of magnetic disk? One is, as I said, floppy disk. This used to be some kind of square, like you have CDs in round form. The floppy disk used to be a square shape. So there used to be one floppy drive, like you have hard drive, CD drive. So there used to be one floppy drive where you used to put your floppy disk. Okay, so this was in last century, I will say 90s only I have seen it, not after, or not, yeah, till 2005, I guess, 2006. Yeah. So it's 15 years back. There used to be these floppy disks. So these were very small, very inexpensive, and you can carry it in your pocket easily. Okay. So they used to have very small size, and you can read also, you can write in that also. Then next is your hard disk, which we just discussed. Okay. So normally it comes in GBs. So then, as I said, there are many platters and many sectors and tracks. So now there is, you can say operating system has to maintain the information about the hard disk, that how much data in the hard disk is free, how much data in the hard disk is occupied, right? So what is the uh, size of files on the hard disk, and who has used how much space. So all this information related to hard disk, so you keep it in one file, that is called file allocation table. Okay, so which operating system maintain, so it keeps all the records of the hard disk on this fat, like which file is stored at which address. Okay, so that you can directly go to that address, right? So this is your read write operation of a on a hard disk. Then again there is one zip disk. So zip disk is like you, for hard disk you have different drive, floppy disk you have different drive where you put that floppy. For CD you have different drive, but zip disk is which is a removable device and which has its own drive. So it comes with its own drive, disk with its own drive, and plus with its own wire, right? So it's kind of complete set, so which comes with complete with drive, cable, power supply. Okay, it's operating software. So this is a complete disk in itself. Okay, so you don't need it has its own drive also, cable also, right? Disk also. So this is your zip disk. Then next is topic is ports. So this is clear. Secondary storage memory is clear. So CDs also have the same kind of working. So in CDs also you have divided in tracks and sectors, right? So and read write head, everything. Yeah, one thing I forgot, like if you have three platters, so there will be six sides, right? Because as I said, data can be stored on each side of the disk. Is it clear? Now, data is not stored on the top of the first uh, disk and on the bottom side of the last disk. Okay, because they are more prone to crash or no hurt. So, on how many surfaces, if there are three disks, so on how many surfaces I can use for reading and writing? Anyone? Tell me. If there are three disks, then how many surfaces
Four.
I can use? Sorry,
But I think it's four.
four, right? Because on the top you cannot store, and on the bottom side of the last disk you cannot store.
Yes.
So there are one, two, three, four. So there are four platters available, four sites where you can store the data, right? So this was about your primary memory and secondary memory. Now, there is some small topic, so that I'm just including here. What do you mean by ports? Anyone? You must be aware or heard of this term, ports. We use this term sometimes with mobile also.
Port is like a connection point.
Yes, so where you ports means like where you connect the printer, where you connect the USB. So you have different ports for that, right? So port is like the interface between the computer and the some external device. Okay, so that is like where you can connect the speaker or mouse. So any external device. So you have some connection point. Okay, some port, that is called port. So from which you can connect the devices to the computer, right? So these are called your ports. So then they, again there are different types of ports also. So like you see for printers you have different ports, right? For monitors you have different ports, for mouse you have different ports, so they can be divided in different types. One is serial port. Serial port means this is like their data travels at 115 kbps speed, and they have generally 9 pin or 25 pin, as you can see. Okay, so this is obviously oldest type of interfaces. Okay, so next is your parallel port. Parallel port is, it has generally 25 pin model. Okay, and they are used for printer ports, right? Scanners or printers. Then next is your, so parallel means multiple bits transferred at a time, and serial means they can transmit one bit at a time. Okay, that's also I have mentioned here, one bit at a time, or parallel means multiple bits at a time can be transferred. Next is your USB, that all of you aware, digital speakers, scanners, no cameras. So these kind of ports can connect up to 127 peripheral devices. You can connect through these ports, and they are plug and play. Plug and play means you don't need to install some driver for that. If you connect USB, it will start reading the USB immediately, right? Like for printer, you have to install the what do you say? Printer. What we need to install before that? Drivers. What we say, you have to install driver for that.
Drivers.
But yeah, but for these are plug and play. Okay, so you just connect it and you can start working on it. So like your USB drives, okay, keyboard, scanners. So this is your USB ports, right? So pen drives and all we can connect. So and I'm just seeing if any point is left or this is complete. So this chapter was about memory. So first chapter was about computers, its generation, types of computers. Second was about input output unit devices. This third unit was about memory devices, right? Primary memory and secondary memory. So this is complete now. Okay. So there is one ports which we say SCSI. Okay, they connect printer or hard disk and drivers and scanner all to the same port. Okay, so but they have high transmission speed than serial or parallel ports. Clear? So their speed is higher than serial or parallel ports. They are called SCSI ports, right? So all these devices, hard disk, printers, scanners, everything can be connected to this. So these was your third unit. Okay, now I'm going to start with the fourth unit. Now just let me open my file. Yeah, visible? All of you can see this? Yes, is my file
Yes,
visible?
yes, it is.
Okay, okay, thank you. So this is your next is about we have done the hardware, right? That hardware, in hardware comes your memory devices, in hardware comes your CPU, input output devices. That all we have read about the hardware. Now next chapter will be about your softwares. Okay, so different categories of softwares, right? So first it is just showing that computer is you can divide it in two categories. As I said, only hardware cannot work without any software. If you just keep a printer, it will not give you printout. You have to connect it. You have to install the drivers. So what are drivers? Drivers are basically the softwares only, right? So hardware and software combination will only follow your instruction and gives you the output, right? So then again, I'm just here telling you that all your hard disk, CD drives, right? Your motherboard, your power supply, your cards, graphic card, sound card, everything, your buses, motherboard, everything comes under hardware, right? What do you mean by buses? Anyone? Yes.
Channels.
Channels, right? So wires through which you transfer your data from hard disk to CPU, or no, any through which your data is transferred. Okay, so these wires, you can say, are called as buses, right? So now we, as I said, we will study about the software. Okay, so now just yes. So, hardware, as I said, it includes all your power supply, also your fan, also cables, connector, ports, everything. It's not only input and output devices. So, all these comes under hardware. Now, what is peripheral devices? Anyone?
All devices that can be connected to computers.
No, input and output device combined collectively, they are called as peripheral devices. Clear? Input and output devices, both
Okay.
combined are called as peripheral devices, right? So now this is about the hardware, right? Now, which you can touch and you can see. Now, what is software? Yes, anybody can describe what is software?
Software can be said to be set of data and instructions that
Yes.
can be used to execute a specific task.
Hmm. Right. So software means any no set of instruction. Okay, so which we want computers to follow. So user will give the instructions, right? So that collection of instructions is called program, and collection of programs makes a software. Okay, so this is like this software will guide the computer at every step. So what to do, how to perform any job, right? So the process of developing the software is called programming. Now these softwares can be divided in two categories: application software and system software, right? Now, and anyone knows what is application software and what is system software? Any idea?
Uh,
Application.
application.
Yes, yes, Lowell. Tell me.
Application softwares are programs that help users to solve day-to-day activities,
Okay.
while,
Any? Hmm.
while
Yes.
system softwares
Huh.
are programs that direct the operation of the computer.
Okay. Very good. Anybody else?
Yes, ma'am.
Tell me.
Application software is a set of programs that allow computer to perform a specific data processing job for the user.
Hmm. Hmm. Yes,
Then
Murtala.
system software is a system software package is a collection of programs designed to operate, control, and extend processing capability of computers.
Okay. Good. Murtala Bala, you also want to speak something?
Yes, it's like they've said the idea already. It's a program that's set up to carry out a specific task rather than the normal computer operation.
Hmm. Right. So, this is, as you said, application software and system software. So, application software means which are required by the user for a specific purpose, right? Your computer can work very well without these application software. Like if you have to create a presentation, you need to have PowerPoint. Otherwise, your system will work without that. If you don't have Microsoft Word, you can work on the computer. So it's like if you have no some accounting, if you are in accounting departments, you need some accounting software like Tally, or no maybe you have some other softwares in your country. So these are like for salaries, for payroll you have different software. So that depends on, like, if you have printing or in marketing, so that depends on which area you're working. So according to that, you use these softwares, right? So for desktop publishing and all that, for no printing purpose. So that depends, like as I said, if you are in banking, so you need different software. So these are basically for some particular purpose. If you want it, you can buy it. If you don't need it, your system will work without these softwares also. But system software are those software without which your computer cannot work. Okay, they are must for your computer to start. Okay, so what is the example of that system software? Anyone? Herbert, Harry,
Operate,
Miriam, you guys are not
operating
replying.
system.
Yes, operating system.
Windows.
Very,
Operating
Linux.
yeah.
system.
Operating system can be Windows, it can be Android, any. So operating system comes under which category? System software. Okay.
Software instance.
Yeah. So there, this is only one example. Okay. There are other categories also of this system software.
Yes, we have Linux.
Linux also. Then there are some utility softwares, right? So there are like drivers, we say, for different devices. So which are, you can say, basic for your computer to start to work. That is compulsory. You every user has to have it, right? But application software which are as per your requirement. If you need it, you have it, or you don't have it, your computer will work without that also. Like you have different apps, right? So somebody, if somebody requires some particular purpose, he will install this app, otherwise he will not install this app, right? So this is the hardware, this is the types of software, application and system. So like you can see, these softwares are between the hardware and user has to take work from hardware only, right? Actually every job is getting done by the hardware only. If you are saving your data, you are saving it on the hard disk. If you are opening your file, you are opening it on RAM, right? If you are taking printout, you are giving using the printer. If you just want to see the output, no, everything, your job is actually done by the hardware only, right? You want to see it on the screen, you want to type your data through keyboard, everything is hardware. But how user give instruction to the hardware, right? So user will give instruction to the application software, where, like, if I'm using Microsoft Word, that is also an application software. And there, if I say sort the data, if I say no, whatever, save the file, so that command is still not understood by the hardware. So that command will go to the system software, like you can say operating system. Okay. Then operating system can give command to the hardware. So your user and hardware, there comes between application software. User give instruction through the application software. Then these application software instructions are passed on to the system software, like you can say operating system. And then operating system will give the instruction to the hardware, or it, no, getting your job done. Clear? Yeah. So as I said, there is application software, system software. The same way, there are utility programs which also come under system software. So utility means, again, for specific purpose, you run these programs for some specific purpose, in order to make your system working efficient. Your system will work without them, but you want to make the working efficient. Like you have mobiles, right? But sometimes you want some unnecessary data to clear from your mobiles, right? So you have, no, you want to clean your hard disk. Okay. So for, you can say, disk formatting, you have some software. You have backup, for taking backup also you have some utility. For data recovery also, right? So these all are like for enhancing the efficiency of your system. But each app will have a different utility program will have different purpose, right? So if you want uh, to make, you can run all these programs for a specific purpose. So these are called your utility program. Okay, they all come under system software, right? So this is about installing and uninstalling software. So you know how you can install. You have to go to start menu, then you go to run option, then CD drive where you have that software. Click on browse and you have to set up a exe in that file. Okay. So for uninstalling software, you have to go to control panel. From start, go to control panel, then go to add and remove programs. Okay. And then you can choose whichever program you want to remove. Okay. So these are just the steps. Yeah. So here I am just again describing the categories. So these uh, uh, can be divided in three categories also in some books. One is application software, one is system software, and one is programming software. Programming software means those software which helps you in writing the programs, in creating a software. So which do you think which softwares come under this programming software? Any idea?
Visual Studios.
Yes. So softwares that can assist the programmers in writing. So have you heard about compilers? What do compilers do? Anyone? Compilers means like as we give instruction in English, right? But computer cannot understand our language, right? So computer has which language? What is the language of computer?
It's binary.
Binary. Now, whatever instruction we give, it will understand and process in binary and it gives the output in binary. But again, we cannot understand that binary, so it will be again converted in user CPU. So compiler is that translator in between which will do this translation. Whatever action or instruction I am telling the computer, it will be converted into the computer language, binary language. Then after processing, completing all the processing, the CPU will again convert this binary result into the our user's language. So this will be translated by these compilers only, which come under programming language. Okay, now we come to the languages. Like languages means which languages we are talking about. We are talking about the languages we use for developing the software, right? You know, there are many languages in which we develop programs, we write programs, we develop software. Any idea which languages are used for that?
Yes, we have Python, we have Java, C++.
Right. So we have Python, we have Java, right? So all these languages are divided in two categories, low level languages and high level languages.
High
Now,
level language.
yeah, high level languages. All these are high examples of high level languages, but programming languages can be divided in two categories, low level and high level. Now, what do you mean by low level and high level? High level means which we can understand, right? So we can understand English and we write programs in English only. Okay, but again, we know that computer cannot understand English. So whatever program we are writing, that will be, as I just explained, that will be converted into the binary by the compiler and interpreter. So they are the translator in between. So if you know, like if I have to install Java, so I will say I have to install its compiler also, right? If I have to install C++, so we have to install its compiler also. Why we need compilers for every language? Because these compiler will translate our English instructions into the computer instruction. Now, in earlier times, we didn't have these compilers. In earlier times, programmer had to learn the system 0 and 1 language. So programmers started learning the 0 and 1 binary language, and then they used to write the programs. So this was your machine language, first of all, right? In initial time when first generation of computers started. So that time the programming would be done only machine language. So programmer started understanding the binary language, right? And but again, no, this was very difficult, and it is, this binary language is different for every machine. This is not like if you have learned it once and then you can write the programs for every machine. No, if you have written a program in binary language or in language for one computer, it cannot be run on any other computer, right? So this was the restriction of those machine languages, that only very small programs could be written. Obviously very simple programs, because programmer, it was very difficult for programmer to understand and learn these machine language codes, right? Now, then after that machine language, then come assembly language. Assembly language means which was machine language plus some English like codes, you can say, right? So where it made a little easier to the programmer to write codes. Okay, so because it used some words like add, move, English like words. Okay, so they could substitute a number of machine codes using these letters. So in low level languages, two languages come under low level languages: machine languages, which is only in the form of the 0 and 1, so which was very difficult for the programmer to learn. Okay, so this was, as I said, in the first generation of language. Then advantage is that it can be directly understood by the machine, so it works fast. Okay, there is no translation required in between, but very difficult for the programmer to learn. Then second comes the assembly language, which also comes under low level languages. So there they started using some symbols, as I said, move, right, add. So these are some kind of which made it bit easier for the programmer. Okay, so it saves their time, they can easily write the program in assembly. Okay, but again, because if you use some English like words in assembly language, so again you need some translator in between, which can convert your English like words into the machine language, because whatever instruction you are writing in your program, you have to make this instruction understood by the CPU. Only then it will execute, right? And CPU can understand only 0 and 1. So whatever you are writing, you have to convert it into machine language, right? So for assembly language, you required assembler. Assembler is that program which used to work as a translator between the assembly language and computer. Clear, all of you? So these two languages come under low level languages, machine and assembly, which was in the first generation of computers. Okay, now but again, assembly for language also, if you have written the program in assembly language for one computer, it cannot be run on any other computer, because every computer has its own machine language, and every computer has its own assembly language also, because assembly language is dependent on machine language. Is assembly language is machine dependent. Okay, so one program written for one computer cannot be run in computers with different configuration. Is it clear, all of you, what is low level language? Yes.
Yes.
Now we come to the high level languages. As I just said, whichever languages you use, Python, Java, C, C++, wherever you use English like statement, so that is your high level language. But what we need for that, how this can be worked, which is very easy for programmer to learn. We can write very large programs also easily. But what is the requirement for that? Anyone? What we need with the high level languages?
Com- Compilers.
Compilation, right? Compilers. We need to install compilers, right? So any high level language compiler will convert this into the machine level language program, right? So it will translate your source program. Okay. So for Fortran language, you have Fortran compiler. For COBOL language, you have COBOL compiler, right? So for each language, you have a different compiler, means program translator, right? So it will translate your program into machine code. Now there are two types of translator. One is compiler and one is interpreter. Now what is the difference between these two? Compiler means which will compile your whole program at once. It will read the whole program and then con- convert it into the machine language. Okay. But what is interpreter? Interpreter will also convert your program into machine language, but line by line. It will read one instruction, then convert it into machine and execute that. Then it will read second instruction, it will convert into machine, then execute that. Okay. But compiler is it will read the whole program, convert it into we call it object code, okay, or machine code, and then run the entire program. Clear, all of you? Difference between compiler and interpreter.
Yes.
So here translation and executions are carried out for each statement. Okay. And compiler will translate the entire source program into machine code. जी नहीं चाहते. Okay. So which is faster? So obviously
Compiler is faster.
yeah, interpreter is time consuming, right? Because it will pick one statement, translate it, execute it, then second, right? So compiled program run faster. Okay. Now we have seen what is software, what is hardware. Now there is one term which is called freeware. What is freeware? Freeware
Uh,
is
A
that is
software that can be used free of charge
yeah, yeah,
without
man.
any
Yes.
charges.
Like Linux, you can install it online, right? So those software which come without any, which are freely available on internet, you can download it and distribute them, right? So these are your freeware. Next is shareware. Shareware means there are some you can say in like Netflix, and no, they give you okay 10 days of trial, right? So they say try it before you buy it. So that is like they give you free subscription for few days. Okay, so you can first try these programs. If you like it, then you can purchase it. Okay, so that is shareware distributions. So you have to pay it, but they will give you a period of time to try these software. Okay, freely, right? So that is shareware. Then what is firmware? Firmware means we say there is one software, there is one hardware. Now when your software is built on your hardware itself, okay, which I was just talking about, like microwave, like fully automatic machine, where you don't need to install software separately. What happened in your microwave? The circuit of that, the chip is already, whatever are your instruction, okay, you build the circuit for those instruction on the chip itself. So you hardwire your instructions. You don't need to install it separately. Okay. So like video card, sound card. Okay. So nobody can make changes in those chip, right? So they are, you can say, embedded program. Clear? So
Yes,
your
please.
your software is embed in that hardware. That means is inbuilt in that hardware. Okay. So these are your firmware. So this was about your uh, software chapter, right? Now let me see. There's one chapter which is number system, but that is very lengthy one. That is a very practical subject. I mean practical topic. But let me see if I can start it today. Or should I start it in the next class? Let me see. Okay, we just start it a little bit and then we see. I'll be able to complete it in the next class only. Right. Let's start some part of it. So next I'm starting is number system. Yes. Is it visible? Yes. Is my file visible to all of you?
Yes, it is visible.
Oh,
Yes,
thank
it's
you.
visible.
Yeah. Just a second. Hmm. So first of all, what is number system? Right? Number system means we use some number system in our daily life, right? So first of all, the number systems can be divided in two categories. One is positional number system and second is non-positional number system, right? Now, what do you mean by positional and non-positional? Non-positional means where the value of the numbers does not depend on its position, right? So, what do you mean by this? You know Roman numbers, all of you. What is Roman numbers, right? So that is fixed. You will write Roman number one as no like this. You will write two like this in Roman numbers. Okay. So just a second. Okay. So this is just a second. Yeah. So this is, as I was saying, one is written like this in Roman number. We write two like this, three like this, Roman number system. So it has nothing to do with its position. Okay. Now, what is the positional number system? The number system we use in our daily life. What is that number system? Anyone? Which number
Numeric,
system we use? Yes.
numeric number system.
Yes, numeric, but that is basically decimal number system. Okay. Kabiru, why you joined so late? Saifuli Suleiman also, you joined so late. This is wrong. Hashim, you also joined so late. Usman Muhammad. So please be on time from the next time. Okay?
I apologize for coming late
Yeah, yeah.
because I
So
have a lot of challenges I have been facing. So that's why I am coming late. I am sorry for
okay.
that.
It's okay, Kabiru. Be on time. Okay. Miriam, Hubbard, Harry, you were also late today, right? Okay. Yeah.
Yes, please.
So
No, I was not late.
who? Hubbard,
No, I was
Harry.
not late.
Yeah, you
Yeah,
joined.
I came earlier today. You can see my attendance.
Okay, that's good. Okay, fine. So, what I was saying, positional number system. So now see why, which number system we use and why it comes under positional number system. We use decimal number system, right? Now in decimal number system, suppose if I write 321, right? If no, if I write 321, suppose. So 321, how you will, what number it makes? What is this 321 if I write? What do you mean by this? 3 to 1? We'll call it 321, isn't it? Yes,
Yes.
right? 321. That means if I write 3 to 1, 1 is at 1's position, 2 is at 10's position, 3 is at 100's position. Clear? That is why 321 means 3 will be multiplied by 100. The value of 3 is 100. 3 into 3, because 3 is at the 100th position. 2 is at the 10th position, so it will be multiplied by 10. 2 into 10, so it value is 20. And 1 is on the 1's position, so 1 into 1, right? But if I write 1, 2, 3, what it will become? 123, right?
Yes.
Why? Because now what I have done, I have changed the position of the numbers. Digits are same, right? But their position gives value of to that digits. So here, because 1 is on the 100th position, so this will be 1 will be multiplied by 100. So what is the value of 1 here? 100. 123, because now 3 is on the 1's position, so 3 will be multiplied by 1. Okay, so that means why we call it positional number system, because here three things matter. One is the digit, what digits you are using. Second is the position of that digit in that number, right, will decide its value. And next is the base of the number system. What is the base of the number system? We use decimal number system, and what is the base of that number system is 10, right? If we use binary number system 0 and 1, what is the base of that number system? 2, because there only two digits are used, 0 and 1. In decimal we use 10 digits. Which 10 digits we use? 0 to 9. Okay, getting it? So there are 10 digits. Whatever number you make, any number in million, trillion, it will be made out of using 0 to 9 only, right? So in the whole decimal number system you will use 0 to 9 only, because in computers every number start, not only computer, in decimal number system also we use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the total 10 digits we can use, right? So this is the number system we use is decimal number system. The base is 10 and it uses 10 digits. So, and what I was explaining, the number system can be divided in two categories, positional and non-positional, right? So non-position means the Roman number where position has no value, but in positional number system, the position of the digit changes the value of the digit, right? So in position number system, we use 3 points. One is the digits, second is the position of the digit, third is the base of the number system. Because this is in decimal, the base is, what is the base?
Base
10.
10.
10. So that is why every number gets multiplied by the value of 10, right? So 1, if I write this number 1, 2, 3, 4, so that means 4 get multiplied by power of 0. Sorry, 0 power of 10, right? So all these numbers will be multiplied by the power of 10, and the power of 10 will start from 0. Okay, 0, 1, 2, 3. So from right hand side you will keep increasing the power, and the power will start from 0. So whatever number is given first, from this right hand side, 4 into 10 raised to power 0. Next is 3 into 10 raised to power 1. Next is 2 into 10 raised to power 2, 3, 4, like that. That only, no, this is how it will become 1000. 10 raised to power 3 is 1000. 10 raised to power 2 is 100. 1 is 10. And 0 power of any number is 1. Clear? So this is how it gives you the value of what you pronounce it, 1234. Right? So how it is calculated? This 1 will be multiplied by 1200. So this is how it comes. Ones place means power 0, tens place means power 1, 100 place means power 2, 1000 place means like that. It will keep on increasing. And then you get this value, 1000 plus 200 plus 30 plus 4 is equal to 1234. Is it clear, all of you?
Yes.
Yes,
Right?
it's clear, ma'am.
So this is the decimal number system. Like I was telling you, if you have a positive number, so the power will start from
0.
0 for these positive or integer numbers. Now, if you have decimal numbers, what is happens in that case? So after decimal, the digits will be multiplied by powers of 10 only, right? Because this is here the base is 10. That is why we are increasing the power of 10. I'll show you in binary number system, we'll do this powers of 2, right? So in different number system, whatever is the base, you give the powers to that base. Now I'm telling you about decimals. What happens with the decimal? After decimal, for fractional numbers, the power starts from -1. Okay, so after decimal, the power starts from -1. So 10 raised to power -1, -2, -3, like that, it will keep on increasing. Clear? Yes?
Yes.
Yes, it's clear.
Yes.
See, whatever topics I'm teaching you in the theory classes, they all are very important. Okay, so uh, these all topics are very, very important. They will definitely come in your exam. Like in the first class, we did input output devices, that is very important. We did types of printer, again, very important. Types of monitor, very important. Right? We did generation of computers, right? Then there is von Neumann architecture of computer. What is von Neumann architecture means? There are 4 units: input unit, output unit, processing unit, and what is the fourth one?
Storage unit.
Yes, storage unit, right? So that is your von Neumann architecture. So I'm just repeating the topics that you must be on your tips. Okay, so prepare these topics accordingly for your exams. So here I was telling you, for integer number the power start from 0, and for fractional number the power starts from -1. Okay, so -1 means 10 raised to power -1 means 1 upon 10. 10 raised to power -2 means 1 upon 100, right? -3 means 1 upon 1000. So like that it will keep on increasing. Okay, so now here I just mentioned the number system that we use in our daily life. That is the decimal number system, right? We use 10 digits and the base is 10. Now there are other number system that we have to study. Okay, so first is binary number system, right? Where the base is 2, and with what are the different numbers used are 0 and 1. Next is octal number system. Octal base is, what is the base? 8. Which 8 digits are used in octal? 0 to 7. Okay, so that comes 8. In hexal number system, base is 16. Okay, so which 16 digits are used? So if I say 0 to 9, how many numbers does that make? 0
10.
to 9, 10. But we don't have more than 10 digits in our number system, right? In total, we use this 10 digits only to make any big number. We use this 10 digits only, numbers between 0 to 9 only, right? Now, for hexa, I want base is 16. So, after 10, what are the other 6 digits that we can use? We don't have any other 6 digits. So, what we use for that? Characters. We use letters A to F. Okay, so A stands for 10 because 16 means 0 to 15, right? 0 to 15 will make 16 digits. Okay, so now 0 to 9, as I said, everything starts from 0. So 0 to 15 will make 16 digits. Now 0 to 9, we have numbers. For 10, what we do? We use A for 10, we use B for 11, right? We
Hello,
use C. Yes,
hello. We are
yes,
not
yes.
seeing your entire screen.
Okay, just a second. Right. So this is
Okay.
just showing you. I'm telling you
Okay.
actually. So this is for A I use 10. For B I use 11. Sorry, for 11 I use B. For 12 I use C. Right. For 13 I use D. For 14 I use E. And for 15 I use F. So what I do? 0 to 9 I have 10 digits. For next 6 digits we use A to F. 6 characters. Clear? So
Yes.
what I will use 0 to 9 and A to F, right? Now next is as I said, in decimal number system base is 10 and in binary number system base is 2, right? So if I am given some number like 0 1 0 1 0 1, so how I will calculate its value? Like what I do when I'm using decimal number system, I pick up the first digit and multiply it with the power of 10. Second digit with the power of 10, 1. Next third digit with the power of 10, 2. Right? But in binary number system, what I will do? I will pick up the digit and I will multiply it with the power of what? Multiply it with power
It's
of what?
number.
Which number?
It's initial number.
Its initial number will be multiplied by power of which number I will use? Power of
10.
2. Can't you see here? 2. 2 raised to power 0, 2 raised to power 1, 2 raised to power. Here the powers will start 0 only. Power always start from 0, but power of 2. In decimal, we have power of 10. Okay. In binary, we use power of because base is 2 here.
It's base 2.
Right. Its base is 2. Binary, we have base is 2. So here I will pick up first digit from the right hand side and it will multiply it with the power of 2 and power start from 0. So it will keep on increasing. 2 raised to power 0, 2 raised to power 1, 2 raised to power 2, 3, 4 like that. So I'll be picking up one digit like I was showing you in this decimal number system. Got it?
Yes.
Yes, we
Clear?
got it, ma.
Yeah.
It's
So
clear.
in decimal number system, we pick up one unit from RHS and start multiplying it with the power of 10. Okay. In binary, we start multiplying it with the power of 2. So this is how we calculate the value of binary number. 1 into this. Now wherever you have 0, it will give you 0. Rest 2 raised to power 0 of any number is 1. Right? This is 0. 2 raised to power 2 is 4. 2 raised to power 4 is 16. So it will give you 21. Okay. So what is the value of this binary number? 21. All of you want to do it yourself once? Yes? Do this calculation once on your own, whether you get this 21 or not. how to calculate this. This can be any number. This is only one example. And now when I will start this, no, this is the complete practical topic. So all of you sit with pen and paper next time. So whatever topic I'll be showing you, explaining you, and then I'll be giving one problem to solve all of you along with me. Okay. So this,
Okay.
right. So this will not be only on the computer. This will be, I want all of you to perform all these steps along with me. Only then you can practice it and you will get these kind of practical problems in your exams also. Okay. So in the next class, be ready with your pen and paper. Right? Yeah. So now
Yeah.
practice it this once on your own, whether you are able to do it or not. Tell me.
Yeah, it is correct. I get 21.
Yeah. So you got it? This is
Yeah.
if you are given
Yes, we
some
got
binary.
21.
Yeah. So this is actually if you are given some binary number, right? So how you can convert it into decimal number, right? Just a second. Just a second. Yeah. Right? So this is your conversion from binary to decimal. You got it? All of you? Right? So
Yes, ma'am.
this
Yes,
we'll
please.
be doing all this number system in the next class, how to convert from one number system to another. So sit with pen and paper. Now, Nick, this one thing I want to explain today, and then uh, from next topic I will be doing in the next class. Now, this is here I'm just showing you the your decimal numbers and their binary numbers. Okay, so that you will be for binary and decimal, it should not be like you need to calculate it. It should be on your tips, right? So how we write 0 in binary, this is 0. How we write 1, so that means on the first position, when you will get 1, like in the first position of this, you should have 1. कर रही हूँ इसमें अभी कुछ अभी So this is how you write 1 on the rightmost position. This is like 1. Okay. Then for 2, what do you want 2? Which number should be 1? 2 raised to power 1. Right? When you will get 2, 2 raised to power 1 should be multiplied by 1. Right? So here it should be 1. 1 into 2 raised to power 1 will give you 1. So here the binary should be 1 and 0. Is it clear? 2 raised to power 0, 2
Yes.
raised to power 1. So 2 raised to power 1 position should be 1. How you will get 3? 2 plus 1. So here what do you want? 2 plus 3. So 2 raised to power 0, this should be 1, and 2 raised to power.
But
Yeah, I'm
how
telling
do we
you.
get 5?
First, let me come. Yes,
Hello?
I'm coming to that.
How do
First,
we
let
get
me.
5?
Oh,
How do we?
so this is 2
Okay.
plus 1. Then how we get 4? 2 raised to power 2 will give you 4. Right? So what you want? 2 raised to power 0 can be 0. 2 raised to power 1 can be 0. But 2 raised to power 2 should be 1. Only then it will be multiplied. Now 1 into 2 raised to power 2. So it will give you 4. right? So it's like this position should be active, should not be 0. Then how will you get 5? 4 plus 1. So that means this 4 position where you get 4, 2 raised to power 2 should be 1, and where you get 1, 2 raised to power 0, this should be 1, right? So 4 plus 1, these two positions should be 1. Clear? How will you get 6? 4 plus 2. So I'm just showing you these numbers so that you should be able to write it quickly, even without computing it. So it should be on your tips. For 6, what do you want? Position of 2 and position of 4 should be 1. So this is 2 raised to power 1 will give you 2, 2 raised to power 2 will give you 4. How will you get 7? 4 plus 2 plus 1. So that means this 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. 4 plus 2 plus 1. Clear? How will you get 8? 2 raised to power 3. So this 0 can be 0, 1 position can be 1, 2 raised to power 2 can be 0, 2 raised to power 3 should be 1. This position should be active. Clear? 8 plus 1 is 9. So position of 8 and position of 1 should be active, you can say. Should be 1. Clear? All of you? Yes?
Not really, ma. I'm a bit confused.
Yes.
So
Ma,
it's
very
not
confused. Not
confusing, you
clear.
just need some practice. If you didn't understand something, you can ask me. Or if you want to practice it, then I'm giving you time till the next class. You can practice it. If you want to ask something, you can ask it.
Okay, can you explain again, ma?
How will you get 7? If here, how will you get 7? 4 plus 2 plus 1. So that means this 2 raised to 0 into 1. This 2 raised to 1 into 1. Because if you have 0, that will give you 0 value only. So if you want the value of 4, so how will you get 4? 2 raised to power 2 plus 1. 2 raised to power 2 into 1. So that means here it should be 1. Then you will get 4. If you want 2, then 2 raised to power should be multiplied by 1. So here you should have 1 on the second place. 4 plus 2 plus 1. How will you get 1? 2 raised to power 0 into 1. So that means this place, this number should be 1. Okay. What you can do, you convert it into this way. Like you convert these binaries and then you get these numbers. Same way you convert all these binaries using this method only and tell me what the number you get. Okay. You can note it down.
Okay,
That is why I given you
we'll
this
give it
one
a try.
problem. Yeah, you give it a try. That is why I told you this, solve this
Excuse me.
one.
On.
Just a second. That is why I told all of you to solve this one problem by your hand. Okay.
Uh,
That only
excuse
then
me.
you will, yeah, just a second. Let me complete. Only then you will understand how these calculations will be done. So you have to convert all these numbers using this binary into decimal. What you did here, these binary into decimal. Same way here you have to convert all these binary into decimal using this method only. Okay, clear? Yes, now tell me what you wanted to ask something.
Yes,
Yes,
ma. I
yes,
want to make some clarifications here
yeah, tell me, go ahead.
concerning this number system. Please, ma, share the screen again. Yeah, this is what I want to say. Concerning this number 7 that is complaining. We can also find it using the method of getting the LCM, meaning we should convert when you convert this 7 to base 2 using LCM or division method, you get the answer without even
No,
going
you
deeper.
don't go and by any other method. You just use this method. What I'm telling you.
Okay.
Start from the power of 0, then 1, then 2, from right to left.
Now this is what I'm saying. Let me show.
You want to share your screen, you are saying.
No, I'm using a handset, so I don't know whether it is clear. You can see it. Let me.
Even it's fine if I don't see it because you should get the answers. These are your
Oh,
I'm just telling you these are your problems and these are your answer. You just see whether by conversion you get these answers or not. I'm telling you
okay.
using this method. You should get these answers. Should get these decimal number like what we got here 21. Same way. So that is why
So
I'm
if
leaving
I
you.
get it right, ma,
Yes.
the binary is the question while the decimal is the answer.
Yes.
All right.
Right? And this is a method for solving it. Okay? So you just solve it how you get 1, 2, 3, 4, 5 like that. Okay? So I'm leaving you on this topic here so that you can practice it till the next class. Right?
Okay, we give it a try.
Yeah,
Yes, ma.
fine. Okay?
Thank you
So
so much.
Can you go back to previous screen, please?
sorry. Yes, Harry, you want to ask something?
Yes, I wanted you to show the previous screen where there's 10101 to base 2.
Just a second.
Where there's an example, yes.
I'm opening it 1 second. Yeah, this one.
The other one, where there's the example.
You're asking me something or you're telling me like what I didn't get you?
I
Yes,
mean,
we want to see the previous
so
slide.
the previous slide, where
Yes,
the,
this
yeah,
one.
yes.
Yes, is it done?
Uh, excuse me, ma'am.
Yes.
Is it possible that a question might come in form of decimal to convert it into binary?
Yes, that I'll come to these topics in the next class. We have very big problems to solve in the next class. This is just
Okay,
the
okay,
very basic thing I am giving you for your practice. Then we have all
okay,
this number system, all the conversions, decimal, fraction, everything we will do. It's just
okay,
very
okay.
basic I'm leaving you with to try it. Okay? Should I close it now?
Yeah, we will try.
Yeah.
Just close it. It is okay.
Okay. Okay.
Thank you.
Okay. So you
Have a
have
nice
meeting
day.
class. Yeah. Thank you. Have a nice day. And you meeting after half an hour. Right? You have practical class with me. Okay. See you.
See you later, ma'am.
Yeah. See you later. All of you can leave the class now.
Thank you.